1. Okay, you guys factor out the common what? Good. 2 is shared on either side of the plus. What else is shared? Cosine of x. So when I divide the first term by that, don't I just have 1 left? Plus, what's left in the second term when I take away the 2 and the cosine of x? Is it sine x left? Okay, now pause and think about distributing. It has to work when we distribute. If the factoring is correct, 2 cosine x times 1 is 2 cosine x, plus 2 cosine x times sine is 2 sine cosine. Does that make sense? Now, factors equal to 0. What have we been doing all, well, yeah, set each one equal to 0. Zach went ahead and jumped ahead and figured out, well, if 2 cosine x equals 0, then divide both sides by 2. Cosine of x equals 0. If you divide both sides by 2. This one you'd have to subtract both sides by 1, right? And so the other one would be when sine of x is equal to negative 1. Just a second ago I said unit circle. We've got to eventually use our unit circle on these ones where they say solve.
See if it's here
Where sine or when sine is negative 1. Where sine or when, sorry, cosine, where cosine is 0. So in my head, if I was using a cheater chart, the sine row is 1, 2, 3. So sine is negative 1, hold on, 1, 2, 3, it's counting up, which means sine will be 1 at the farthest right. What angle is on the farthest right of our unit circle? 90 degrees. However, sine is not a negative 1 at 90. Where is sine going to be negative 1?
Second and third quadrant?
In between, well, sine is going to be negative in the third and fourth quadrants because all students, all are positive. Sine is positive. Sine's negative in the third and fourth, but I want the angle that relates to 90 in the third or fourth. Where's that? Negative 90 or 3 pi over 2. Or 270, I heard that one too, yeah. 270 degrees, or 3 pi over 2. 3 halves of. So that's where sine, or the y value, is negative 1. But we're also looking for where cosine is 0. So 1, 2, 3 is sine. 3, 2, 1 is cosine. Cosine counts down, so when is cosine 0? Also at 90. And the nice thing is, not only pi over 2, but also 3 pi over 2, because 0, positive, negative, doesn't matter. So not only is cosine 0 at 3 pi over 2, but it's also 0 at pi over 2. If we put the two combined, we say, well, what will make this whole thing 0? Well, any of these will. And I don't need to write 3 pi over 2 twice. No purpose in writing it twice. Up here at the top though, if I had pi over 2, this would be 0. This would be 1 plus 1 is 2, but 0 times 2 is 0, that's okay. At 3 pi over 2, they're both 0. 0 times 0 is 0. So different ways of getting 0, but both of them will get a 0 for sure. But guys, where did I have to start? What was the very, very first step in solving? Not factor. That was the first step in the algebra. But the first step to starting the problem? Use the formula to plug in and substitute. Yeah, that 2x in there I was stuck with until I used the formula. Now, let's see if we can use the formula in another way. I want you guys to go look in section 5.4 after you finish writing this down. Go look in 5.4 until you can find the example where I had you star, highlight, circle, the type of problem where you are given a ratio, and I told you what to write down to give yourself a hint for what you needed to do. Any and every time you were given a ratio. Try to keep it a secret for a little bit longer. But if you can find it in your notes, after you write down the example, go back and look. Did you write it down? Given a ratio, and then those of you that do find it, okay, then do what it says. see what it says. Filling in what you know and filling in what you need to still find. Meanwhile, I'm going to go ahead and pass out the quizzes from 5-1 and 5-2. We do have a test coming, and so it would be very helpful to go over these quizzes. It would be very helpful to go over these quizzes. But work on the problem first. Go look in 5-4 notes. Did you look in the 5-4 notes? At the example where I said, given ratios. Look at your 5-4 notes. That's what you're supposed to be doing. There was an example where we started, you were supposed to highlight given ratios. What were you supposed to do? Grade C. And then Noel, if you wouldn't mind going to the library asking for feedback. Rachel. Lindsay. This is alphabetical, I think. Caitlin. Lynette. Check. Okay, on this quiz, kiddos, every problem was worth 2 points. There was the bonus for those in class of the rearranged formula that some of you guys got. I did give partial credit for sure. For numbers 1 and 2, if you got it wrong, I gave you the final answers that you can compare to. Numbers 3, 4, and 5, you knew what you needed to get. It was the other side. Some of you showed getting there, but you missed some steps, and that was okay. I told you you could show the format and yet not fill in. I gave a half point for formatting and 1.5 points for filling in the in-between. But is it going to be helpful to figure out how to do these 5 problems for the test? Of course. So, in a different color than pencil or blue, in a different color than pencil or blue, correcting either in the problem if you can fix what you did, or if you can add to what you did to make it right, or maybe just scratching your work entirely and showing how to do it correctly. These corrections are going to be due on Wednesday. These corrections are going to be due on Wednesday. You can ask people in your groups for like a question that you missed in the first couple of minutes of class while you're waiting for me to get started. You could come in and ask me during lunch or after school. Sometimes period 7. Today I'm helping with some sub-duty. Mrs. McCrae is out today. But sometimes during period 7, if you have like athletic PE, and that's a good time for study hall. But after school, during lunch, you can ask me questions or people in your groups. Wednesday we'll go over if you have any other questions on this after the formula portion of the test. That kind of needs to happen first things first on Wednesday. Remembering, once again, there are 2 parts to our test, right? Wednesday, you're filling in formulas. I give you a category, I give you some blank ones you fill in order, basically as to how we cover them. That's how they're going to show up on the quiz as well. The test, it is worth 25 points, although there might be 26 possible. There might be a bonus one in there. But that's 25 points out of 100 for your test. And then on Thursday, I have a printout of all the formulas from chapter 5, from 5-1, 5-4, 5-5. And you will be able to use those formulas on Thursday to solve problems. But today we're going to practice with these new formulas. Can we use these formulas properly and well? And that's what section 5.5 homework is about.
Sorry, 2 questions. One, are the corrections going to be worth any makeup?
Oh, I didn't say that. The corrections in non-blue, non-pencil pen, if you are able to show me how to do it correctly, hopefully correcting your work, but if it's too bad, scratching and showing is worth half points back.
Okay. And then, is the test going to be multiple choice and short answer?
Yes.
Okay.
Yes, short answer could be anything from a problem like this where you're given ratios and you make, would you guys figure out how to finish the statement? Make a triangle, good. Or it could be a solving equation one, using the unit circle like 5-3, or a T-proof. I'd say all three of those types are pretty good ones for long answers. Okay, where did you guys put your triangle for number 21? What quadrant? Why the fourth quadrant? Because 3 pi over 2 is right here. And 2 pi is right here. Well, 0 and 2 pi. But if we're going between 3 pi over 2 and 2 pi, we must be in the fourth quadrant. So, in your notes we stated, given a ratio, make a triangle. So make an ambiguous triangle if you want, like a general one. You're like, I don't know. What were you guys able, if you were using that example in section 5.4 to help, what were you able to fill in the triangle with? Hypotenuse, good, and the hypotenuse was 5. And what else were you able to fill in? The opposite, which is? Good. And remember, when you have this big old angle, which is u, he's huge. He goes all the way to the fourth quadrant. We make a triangle with his reference angle, and so it's that opposite, that hypotenuse. But what are we missing? Yeah, the adjacent, because sine only gives us opposite and only gives us opposite along with hypotenuse, not adjacent. Some of you remember it from geometry, but if worse comes to worse, you could always do -3. Come on, smart boy. Squared plus unknown squared equals 5 squared. You could solve. You would end up with x squared equals 16. What side is this? Yeah, this would be 4. And why am I going to make sure it's a positive 4? Because it's moving to, well, it is a 3, 4, 5 triangle. That's true. Some people memorize it. Some people would use Pythagorean. But how do I know it's a positive? It's going to the right. Remember, horizontal measurement going to the right, positive, going to the left, negative. Vertical measurement going up would be positive, but going down must be negative. Now, why did I fill in the triangle? Well, I had you guys look in your notes, and your notes said given ratios, solve for triangles, or make triangles. But what are the directions actually asking us to do? Okay, find values of this guy, and this guy. My question to you is, can I steal the opposite over hypotenuse from the triangle to fill in this sign? Can I answer it with -3/5 and be done? No. Why? It's not u, it's 2u. Right? So it doesn't correspond. At least it doesn't match perfectly. Ah, I struggle. So there's no way to solve it. Oh, I know. Plug this in to the u spot, right? Isn't that just equal to u? No, what does it equal? Oh, well, I can't plug it into just the u spot because it's sine of u. So kiddos, go look at your double angle property. Isn't there a way using the formula right up above to break apart to transform this expression? Yeah. And Jane, I see it nodding your head. What can I change it, transform it to be?
Sine u, cosine u?
Almost.
2
sine u, there you go. Cosine u. And that's good because I know what sine u is. They gave it to me. They said sine of u, the whole sine of u, which is what I'm going to substitute, is equal to -3/5. Common mistake is to plug it in for u, but it's not u. -3/5 is the sine of u. So I can substitute for the sine of u to be his opposite over hypotenuse. And now that I've made my triangle, what can I keep on doing, or what can I plug in next? Yeah, cosine of u is 4/5. Since I made my triangle, I was able to see the cosine, even though he wasn't explicitly stated at first. Then I can go ahead and solve. Those of you guys who don't like fractions, you might want to put the 2 over 1. And the denominator, 5 times 5 times 1 is 25. Anybody in mental math the numerator yet? -24. Good. 2 times -3 times 4 is -24. So I could not plug in the -3/5 until I had a place for sine of u. The formula gave me that place, so I plugged in. Is there a formula for cosine 2u? Ah, there's not just one, there are 3. You get to choose. What do you want to use, the first, second, or third? looking at that table of formulas for cosine 2u. I'm not sure if really one's that much easier than the other. What do you guys want? First, second, or third variation? First, all right. So the first one says, I need cosine squared of u minus sine squared of u. Now, am I writing this a little bit differently than your formula has it? Check it out. I wrote it differently. Why? In the formula, yeah, the squared is usually on the inside, but what am I trying to remind you of by writing it this way? When the squared is on the inside, it means all of cosine is squared. So in order to do cosine squared of u, I can literally say, well, who is cosine of u? And let's square it. Exactly. So cosine of u, we already said, was 4/5, right? And then we already said sine of u is negative 3/5. So that notation, even though it looks a little funny, remember, the squared on the inside is just a snazzy way of writing the entire cosine of u function squared. And the entire sine of u function squared. At which point now it's just simplifying. 16 over 25 sound good? And then minus 9 over 25. Careful, the negative squared becomes a positive, but you still have the minus. So final answer would just be good, 7 over 25. You're okay. Now, kiddos, if we needed to keep going, we would. The tangent to use is going to be a little messy because we've seen before in earlier tangent formulas they have denominators, which means you have some complex fractions. But I want to make sure you have the idea, because there are some trickier types of problems coming. The idea of how to solve, start with a formula. Plug in what you know, make a triangle for what you don't. Then you can plug in, the trig is now all gone, the ratios are plugged in for the trig, and the name of the game is just simplify. So once again, when you're given ratios, what do you need to make? Good, given ratios, make a triangle, fill in the rest of the triangle, come back and say, can I plug in right away? No, I had sine of u, not sine of 2u. So therefore I'd say, wait, is there a formula for that? The answer was yes. And then I was able to use my triangle. Is there a formula for this? Yes, I was able to use my triangle. And guess what this one's going to be? Is there a formula for this? Yes, use your triangle. And simplify. Okay, double angle formulas. We've practiced with them a little bit, and we've practiced two types of problems. Section 5.3, solving. Section 5.4, given ratio, make triangles. Let's go play with that second section of formulas. Remember, these ones also you need to study for the formula quiz. There are like 5 sections of formulas in section 5.5. I think the title is, what, more trig formulas? Yeah, great, thanks. There are 5 sections. I'm only saying that you need to memorize 3 of them. But this is another one that's important. I'm going to go steal the directions from the next page, because this is how the book says to do these examples. Let me freeze the screen so you guys can write the formulas. Uh-oh. There we go. Let me go steal those particular directions that you can see what the problems look like. There we go. There we go, there we go. Okay. So these power-reducing formulas say, okay, give me somebody squared, and I'll give you a trig function that's no longer squared. There's more to it than that. But why they're useful is that you can take a squared and make it unsquared. Not in itself, but take a trig that has been squared and get some sort of trig expression where cosine is to the first power instead. And just trust me, go talk to a Calc BC kid and be like, hey, is that a helpful thing to take a squared and make it not squared? It can be, for sure, for sure. You guys just won't fully understand if I tried to show you as to why or how. But it can be useful to go from these to these. So once again, the directions are saying rewrite in terms of the first power and it's squared. Wait, I need to reduce the power. I need to use these formulas if ever I have a power and I want to bring it down. So, you guys can hopefully tell this one applies to the third example up there, right? But what looks different? Something looks different. 3, there's a 3 in there. These formulas, just because they have a u, which sometimes we do make an x, right? Sometimes we can make it an x, change everything to an x. Sometimes we can plug in something besides an x or in addition to an x. We would call this a multiple argument or a multiple angle. We can actually use the formula even though there's a 3x instead of like a normal x or a normal u, and here's how we use it. We set up our formula, 1 minus cosine 2 times 1 plus cosine 2 times. Remember, these little arguments or these little ofs just show us inputs. Just say, oh, okay, cool. Whatever goes in that parenthesis, I'll put them all over the place. Whatever is in the parenthesis belongs in the other places. These are just little placeholders, right? So even though this expression doesn't have a u, it does have a 3x. So guess where else the 3x is going to go? Yeah, on the other side. The formula still works. Just instead of just a u, it has a 3x. And I'm like, okay, cool. So 2 times the 3x, because that's who's inside. And when we simplify, it's not going to look exactly like up above, because you're doubling, the formula says double the u. I'm doubling the 3x, which means I'm going to get cosine 6x. And down here, I'm going to have cosine of 6x. And I actually don't need to do anything else because the point of this formula is to take the squared and make it a single power of cosine, which is exactly what I just did. So even if the u gets replaced by a number with x or with t or with theta, I still just take that whole piece and plug it in wherever there's a u in the formula. Something helpful to see. Now I'm going to show you a harder example using the power-reducing formulas and give you a hint. I might not solve it all the way, but give you a hint, just in case you see one like it in here. Can anybody tell why this is a little bit harder even than the last one? Yeah, it's to the power of 4. And what are all the power-reducing formulas based on? Squares. Yeah. Does anybody have any ideas how to take a power of 4 and somehow rewrite it to have squares instead? Square root would be a good idea if I had an equals and another side. I could take the square root of both sides, but I don't have another side. Yeah. One way is to say, well, sine to the 4th is sine 2x, sine 2x, sine 2x, sine 2x, written 4 times. So couldn't I group 2 of those to be a sine squared? And then group the other 2 to be another sine squared? Then I could take my formula for both of those. Guys, help me out, keep me honest. Not the strongest of these. Is it 1 plus? 1 minus for sine squared? Okay, 1 minus cosine of, why am I putting 4x? Did I read it wrong? Because it's the sine squared one, and the sine squared has a minus. The cosine squared one has a plus, but I'm using this one. But why am I putting, there should be a 2u, why am I putting a 4x there?
You multiply 2 times 2x.
Good. 2 times the 2x is 4x. We do the same thing here. 1 minus cosine of 2 times u. 2 times 2x is 4x. Here's the struggle. Some of you guys would look at that and say, hey, both cosines are to the first power. And I agree that these cosines are to the first power, but the struggle is what's happening to both of these guys? What's going to happen when you multiply? You're going to get a square. Let me show you how that works. You're going to get 2 times 2 is 4. That one's kind of nice. Numerator we have to FOIL. Long story short, 1 minus 2 cosine 4x plus cosine squared of, some of you might put 16, don't. It's cosine of 4x times cosine of 4x is just cosine squared of 4x. The argument remains the same. I'm almost down to the first power of cosine. What's my struggle? Yeah. So then we could just take this guy and say, hey, I have a formula for you. We have to take it all the way down to the first power of cosine. So our job actually would not have been done yet. We would have needed to go ahead and use the formula again. It's a complex fraction because there's a fraction within a fraction. Can anybody tell me why I left this blank or what should go in this space if I'm using the the power reducing formula for cosine squared? What would be right here? Yeah. Because remember, the double angle formula says, hey, whatever's inside the squared guy, I'm going to double it. Whatever's inside the squared guy, I'm going to double it. So who is inside the cosine squared? 4x. So what happened in the formula? Double. Now technically, to make it all nice and pretty, you'd have to simplify this complex fraction. Wow, I'm doing way more than period 2, but that's okay. They had technical difficulties. Do you remember who I'm going to circle? For my shortcut? For complex fraction? The 2. Yeah, he's the guy that's stuck. And then multiply top and bottom by that guy. Just don't forget to distribute. And we'd end up with 2 minus 4 cosine 4x. This guy, the 2's would cancel and I just have my 1 plus cosine 8x all over 2 times 4, or 4 times 2 is 8. Even though I know it looks really crazy, and way harder than the beginning expression. 2 plus 1 is 3. And even though we can't even combine these cosines because one has a 4x and one has an 8x, for those types of calculus problems I'm thinking about, that's way easier to deal with than the beginning one. Way, way, way easier to deal with. Now we're just saying, can we play with the formula? Can we play around with it? Can we use it? I'm just trying to help you guys realize that it does get pretty practical later on. But we did have a complex fraction. We did have to kind of simplify him to make him pretty. And it was kind of weird plugging into the formula. But it's possible, even if you have a 4th or a 6th or an 8th, you could do sine squareds multiple times. You just might have to use the formula again, like we did, to truly get it all the way down to the first power of cosine. So even though it's a 8x, even though it's a 4x, it's not cosine squared anymore, or the third order, the fourth order. All right, so we use the power reducing properties a couple different times in a couple different ways, mostly just in rewriting, like section 5.1 type stuff. How about these guys? Half angle. This is the third and final section for studying formulas for Wednesday. And I'm not sure if I gave you guys this hint, but for the half angle formulas, I don't think they're going to be a regular credit question, but they might still be helpful. I don't think they'll be a regular credit question, but they might still be helpful to you. Some of you, since they're not going to be regular credit, it might be easier in your brain just to skip it. Some of you are like, nope, I need all the points I can get. But half angle formulas, let's figure out if we can learn how to use those. And there is a note, if you guys can see it, watch out for the sign. The tangent one, the sign just happens like normal. It just naturally occurs, whatever the math tells us. The problem is for sine and cosine, both of them have a plus or minus. And the dilemma is that we have to choose the appropriate sign. Based on the problem, we have to choose the appropriate sign. based on the problem, we have to choose the appropriate sign. It's not gonna naturally happen. We do all the math underneath the square root, and then at the very end, we say, all right, which one seems to make sense, the plus or the minus? Which one seems to make sense, the plus or the minus? I'm going to show you pretty quickly how to use the half-angle formula on this problem, because it's kind of tricky. They don't even say, like, use the half-angle formulas. They say, find sine of 105. And you're like, okay, unit circle, right? No big deal, 105. Okay, it's 90. It's 90 plus a little bit. 90 plus 15, that's weird. If that's 105, its reference angle is 75. Question, is 75 something from our unit circle? 30, 45, 60, no. The struggle is there's no unit circle way to solve 105 outright. But if we realize that 105 doubled is a nicer angle, 210 cut in half. 105 is 210 cut in half, or 105 doubled is 210. Then we could use the half-angle formula to say, wait, 210, I don't mind him. 210 is 30 degrees past 180. That's a legal unit circling one. And so if I were to go to my formula up here and say, wait, if I had this over 2 thing, I can use this formula right here, the plus or minus, I don't know. We'll get back to it. But the square root of 1 minus, I just need to figure out who is cosine of 210. The weird thing is, we've been doing radians so much, it might be kind of hard to see that. 210 is a 30 degree in the third quadrant, or 210 is also 7 pi over 6. For my cheater chart people, 1, 2, 3, those are sines. 3, 2, 1 are cosines. 3 is at 30 degrees. So this is going to be a square root of 3 over 2, 1. Which is kind of rough because there's a lot going on as far as simplifying. You would need to do your nifty little, okay, that 2 is kind of stuck. Let's multiply top and bottom to get him unstuck, complex fraction-y stuff. But we've kind of just reviewed the complex fraction-y stuff. What I'm more concerned about right this second is, do you know how to choose the appropriate sign? Question, guys. Plus or minus, which one makes sense in this example? Minus makes sense of the 210, because all students take sign would need to be negative, but the problem is, even though we're using the 210, who are we actually solving for? Struggle, right? And 105 is in the second quadrant. What sign do I need for this guy who is my actual problem? All students, sign needs to be positive. And then we would go ahead and simplify. But we're going to choose the sign based on the quadrant of the, not the answer from the math, like the one I'm using, the actual angle I'm trying to figure out. Here goes, here's the good news. We've done examples of all the formulas that you need to study. Double angle, power reducing, and half angle. I want you guys in homework, if you get to something where you see product to sum or sum to product, go ahead and just stop there. It should be a little bit later on in homework, maybe not the beginning. Unless you're filling in the formulas you can get from the section. Any problems with product to sum or sum to product, go ahead and stop. Sound good? Otherwise, attempt homework tonight.